Thank you for your interest in our presentation. We are going to continue with an explanation about how to make a Wheeler diagram. In this third part, we are going to apply a Wheeler diagram into a sequence stratigraphic framework. Try to understand how to make a Wheeler diagram of a typical depositional sequence in the sense of Bale and others. Now I'm going to move into the drawing board to make some drawing and some explanation. Now I'm going to draw a typical depositional sequence. I will start with the top of the previous depositional sequence. Then we are going to have here, above this sequence boundary, the low stand system track. Basin floor fan. Then we have the slow fan. Or the low stand prograding wedge. Of course, we can have here incised valley fill. And on top, we start with the transgressive system track. Until we reach the maximum flooding surface. After that, we have the high stand system track, with some top lap on top, until we have here the next sequence boundary. We can add also here some phases changes into more continental deposits. So, at this point, I'm going to add some numbers to this depositional sequence. This is a depositional sequence, a conformable succession of beds and bed sets bounded by unconformities or their correlative conformities. So I will going to put some numbers here for the previous sequence. 1, 2, then we have 3 here, 4, then we have the slow fan. We are going to put in the slow fan 2 intervals, 5 and 6. Then we have for the transgressive system track, you have 7, 8, 9, 10. Of course, probably the incised valley is also filled during 7, during the beginning of the transgressive system track. Then we have 11, 12, 13, 14, 15, and 16. So we have the numbers of the complete sequence. Now we are going to build a Wheeler diagram of this depositional sequence. First of all, I will make a grid here with 16 positions. So I will put some number here. This is a time series, and this is the distance. Of course, for making this diagram, this is handmade, but of course all these represent the same time for the accumulation. So at the beginning we have this previous unit. You have the 1 and 2. For example, the 1 unit, the base of the 1 unit is more or less here, and the top of the 1 unit is more or less here. So at this point I can put a line here, and for this first unit you have the end of this unit, the 1, more or less here, the top, and the base is more or less. So this is the deposition of unit 1. Then we have the unit 2. We have on 2 some incision at this point, and another incision more or less here on the top. Then we have the top of the 2 is here, and the base is more or less here. So this is unit 2. I will put some colors just for reference. Okay, what happened now? We have the 3 unit. For 3 unit, base and top is more or less here. The top of 3 is at this, top of 3 is at this point. Base of 3 should be somewhere here. So this is unit 3. And then we have unit 4. It doesn't matter the thickness of the unit. The important thing is the time lapse for the different unit. For example, this is unit 4. The top of the unit 4 is more or less somewhere here. So I can trace here. So this is unit 4. Basin floor fan. Then we have slow fan, or the loft and prograding wedge. For the 5 unit, the top of the 5 unit is more or less. Then we have the same. We can trace here also the phases changes. So this is unit 5 with Then we have Unit 6. Unit 6 is progradational. So the top of 6 is more or less here. So we have this progradation, and the top on this other side so this is basin floor fan. This is the slope fan, both part of the low stand system track. After this progradational unit here, we have the transgressive system track. For the transgressive system track, we have Unit 7. Unit 7, the top of 7 is more or less here, and the base of 7 should be somewhat here. The same, we have the top here and the base here, so something like this. And we can mark here the phases change. Okay, this is 7. Then we have Unit 8. I'm going to put here the phases change. Then we have 9. Then we have the last, our last is the 10. The 10 okay, I forgot the incise valley. For example, when we draw here the 7, then we have in some position here the infill of these incise valleys. The erosion of the incise valley and the filling is detached, as you can see here, because the erosion is on Unit 2. Okay, this interval from 7 up to 10 correspond to the transgressive system track. Then we have the high stand system track. For the high stand system track, as you can see, 11 is more or less here, the top, and the top of 11 is somewhat here. Then we have 12, 13, 14, '15, And then 16. For 16 is some like top lap here. This could be also a type 2 sequence boundary or just a top lap. At this point, we can put here the two sequence boundary. First sequence boundary here, the second sequence boundary here. In the middle, we have our depositional sequence. With this last element could be the high-stand system track. It's very interesting because we can mark here areas of erosion. I will mark the erosion here. Erosion or bypass. Erosion bypass, non-deposition. In this case, we can have erosion also here. I don't know. Then we have some areas on non-deposition. Non-deposition. Non-deposition, I will mark with some cross line here. This is time never accumulated because was out of the depositional system. And finally, we have these internal areas, all these areas in which is condensed in the maximum flooding surface. For example, the maximum flooding surface is not real a surface. It's a time condensation in this area. So I will put another different because this is time of condensed time. So the time in these areas is condensed probably because the maximum flooding surfaces of the downlap surface at the bottom of this high-stand system track. This is the downlap surface. This is the beginning of the transgression. You can trace here the transgressive surface here. And of course, as we can see, the sedimentation is continuous. Of course, we can go from here up to the basin floor fan, then the slope fan, the transgressive system tract, and the high-stand system tract. But the deposition is is located to some point. Other points are areas of non-deposition or areas of condensation. And all this stuff is possible because we have this Wheeler diagram. Wheeler diagrams are very important for illustrating the time series, not only as in a cross section, for example, but also in showing the location of the areas main subject of accumulation. So, thank you very much for your interest in this Wheeler diagram.